Hey everyone, this episode is being recorded in the shadow of some pretty horrific events happening to Israel, which is where I'm from. Jonathan and I talked about it, and we decided to try and do an episode as normal. This is not a politics show, this is not a news show. Well, it's news about Go, but not news. But please take into consideration that that's the situation that myself and people near me are experiencing right now. We hope it won't affect the episode too much. Also, this show is sponsored by koyab.com, a developer-friendly serverless platform to deploy apps globally. Stick around until the ad break to hear more about Koyab. This is Kappa Go for Friday the 13th, October 2023. Keep up to date with the important and spooky happenings in the Go community in 15 minutes per week. I'm Shai Nechmad.
And I'm Jonathan Hall.
What releases do we have? Anything spooky?
We do have something spooky. There's a big security release that came out this last week. Go 1.21.3 and 1.20.10 have been released. And this includes a release for net HTTP that solves a rapid stream reset that can cause excessive work. So potential DOS type of problem. So be sure to upgrade quickly if you haven't already.
And if you have HTTP servers, which is probably everyone, right?
Just about everyone.
Other than that release, we don't have any major releases known or planned. But we are getting near 22, right? Should be like in January-ish.
Should come out in probably February. I'm rooting for Valentine's Day. I don't know what day of the week that is.
So it's coming up. We're halfway there. So if you had a thing you really wanted to put into 1.22, then now's the time to talk about it. But not if that thing is 0, right?
Right.
What happened with that proposal?
You may recall we talked a few weeks ago about the proposal to add an untyped 0, sort of the cousin of nil, that you could use in various places to do equality checks, to check if a struct is 0, or to do like return 0,0,0, error instead of return whatever you might have to do to get 0 types for your structs and whatnot.
Important to note, since this is an audio format, that the keyword is actually ZERO. It's not like the number 0, right? It's a new keyword in the language that's 0 spelled out.
Correct.
But isn't that nil?
Yeah, so the original version of the proposal was that it would kind of duplicate nil. It would be valid for all types. They retracted that and changed it to be only for types where nil isn't applicable. But now it's been, and it was accepted. We were expecting this in Go 1.22. It has since been retracted.
I didn't know that was even an option.
I didn't either.
Something was accepted, it can get unaccepted.
Yes. Well, I think that's kind of nice to see happen. I've heard some people express the idea that the Go team sort of railroads their ideas through, and I've heard people say that about particular proposals. We know this is going to be accepted because it comes from the Go team. I think this shows that that's not always true. The Go team has some humility. Russ Cox has said, quote, "This discussion has made clear that we're not ready for this change," retracting the proposal. So even after it was accepted, people kept talking about it and bringing up some concerns. One of the concerns I thought was interesting was that if you add this keyword, it becomes possible to do equality checks against all structs, even those that otherwise are not possible, sometimes intentionally. And the person who made the point pointed out that you'll sometimes see a struct that has like an empty array in it specifically to prevent equality checks. So this would circumvent that author's intention to circumvent equality checks. And there were other topics brought up too. TLDR, it's been retracted, at least for now. Maybe something else will come along later. But if you were really looking forward to 1.22.0's 0 support, it won't be there.
Well, I think that it's not a feature as much as it's syntactic sugar. So we could just wait until, we figure out all the kinks and whatever and manage to implement it. And even if we never implement it, it's not the end of the world. It's not super important.
I would agree with that, yes.
But it is really good move from a Go team side to be able to retract it. We will get back to proposals. We do want to do conferences and meetups real quick. So I want to shout out a specific conference or a meetup, Go Israel meetup, which is, the main meetup that I'm participating in. I recently lectured there, and our first interviewee, Miki, is the organizer, are coming to my workplace Orca Security. So I recently joined Orca Security and started setting up Go advocacy there. And the first thing we did was set up a meetup. We have a really cool lecture coming up. If you're in Israel and you write Go, you should come. Right now it's scheduled for November 7th. Obviously, because of the war, this might move. So make sure you subscribe to updates. But it will move, but it'll happen. So come join us at Orca. You can meet me and get some swag.
Awesome. Here in Amsterdam, we just did our meetup last week in Utrecht. We usually do it in Amsterdam. We did it in Utrecht, which is about an hour away for those who aren't familiar with the geography. It was a really great meetup, and we're preparing to do our next one November 21. So if you're in the Amsterdam area, be sure to sign up for the meetup group in Amsterdam and be notified about that when it's finally announced too.
Are you Dutch enough that when you say 1 hour away, it's public transport 1 hour away?
Good question. So in this case, it's 1 hour away from me, whether it's by car or public transport. It's like a 5-minute difference in this particular case.
You Europeans and your public transportation infrastructure.
But yes, generally I would say an hour away to being by train.
Damn you and your bikes and your trains.
Yeah, I wouldn't ride my bike there. That would probably be about 3 hours or longer. Moving on.
Public transportation and infrastructure jealousy aside.
So we have an interesting proposal. This isn't really about Go, but it's about the Go ecosystem. So there is a proposal that has been accepted. Basically kill the wiki site on GitHub and move it into the Go website. The main reason for this is to avoid spam. Basically, it's not possible. GitHub doesn't give the control to lock down wiki edits or to require approvals of them and so on. So basically anybody is free to go in and change the wiki. Please don't do that unless you're making legitimate changes. But, there's been some spamming happening. So it will be moved to the website. It's still possible to contribute to it. You'll just have to go through the pull request process to do that.
Which I think is overall improvement, right? Yeah. The review benefits would be really good. And also, since I think 2 or 3 years ago, GitHub doesn't allow crawling wiki sites. So you wouldn't find that content on Google. So, compared to like official documentation, website content, the wiki is just, it's bad when writing because it's like world writable. It doesn't have a review process. Mm-hmm. And it's bad reading because it's not very searchable. So it performs worth on both sides of the equation. Exactly. So I think it's a really good move. And I'm happy it's accepted.
And it will affect a minority of people negatively in the sense that it'll be harder for them to contribute. I will be one of those people. I tend to edit the conference's wiki page almost every week as I'm preparing for this show. And that will be a more involved process, but still overall a net gain for the community.
So I think I know that in my previous company, we had very strict code review process. We had to fit to regulations and whatever. So like most companies. But for documentation PRs, we just had, we allowed self-approval. We just checked in CI that there is no something like that. I'm sure that the Go team can rig up, if it changes to these pages, if it comes from trusted authors, they can self-review and they can self-approve the pull request, something like that. If it just changes in the docs folder.
Yeah.
But we'll see. We'll see what they set up.
So one interesting fallout effect from this is, you may recall we talked in the past about the discussion or the proposal to remove the bridge between GitHub and Gerrit for pull requests. I think this likely will kill that. Because for documentation updates, we want it to be as relatively seamless or painless, and GitHub pull requests are probably the easier way to do that. So as I understand, the proposal is to use GitHub to do pull requests for documentation, which probably means not getting rid of that GitHub to Gerrit bridge that they talked about removing.
Which is, again, another move from the Go team to, accept more community contributions, even at the cost of maintaining more infrastructure. So kudos to them. So last week, Adelina and yourself, it's a good chance to shout out. Thanks, Adelina, for covering for me while I was recovering from COVID. Your episode was really good. Second timer, third timer, actually, if you count the interview.
That's right.
So a huge part in making this show. Thanks a lot, Adelina. We appreciate your work and your book. Go buy Adelina's book now. So last week, you and Adelina discussed about another interesting proposal about encoding JSON. So what's going on there?
So I subscribe to this discussion on GitHub, and I have to say I don't like the way GitHub handles subscriptions to discussions, because within a discussion you have all these little threads, and I'm only interested in some of them. but I get notifications for all of them. I've been getting hundreds of notifications. This is a very, very active thread. If you have any interest in JSON marshaling or how it should or shouldn't be done, I encourage you to go read the thread. Let me just highlight a couple of things that have been discussed. One of the main things to be discussed is what should the defaults be. So let me give a really simple example. If you've done JSON encoding with the current implementation, you already know about omit empty. Which you put in your struct tag to say if this field is empty, then just omit it from the JSON output, as opposed to producing null or an empty map or something like that. They're planning to add an omit zero option also, which complements omit empty and would particularly be useful for empty slices and maps and stuff like that. So rather than having, say, empty curly braces, you could just delete the field entirely. There's an open question. Well, what should the default be? Should the default be that you omit empty or that you include empty and you have to turn it off? So, there's this question. There's many other questions about what should the defaults be. Like we know we need an option between A and B. Sometimes A is the version 1 capability that's maybe broken, but we still need to enable it for compatibility's sake. Sometimes it's a completely new thing. What should the default be? So this has come up many, many times. What should the default behavior be for this thing, for that thing, for the other thing? So that's a really good one. And then, of course, people have been just bringing up proposals for, can we handle this thing or that thing? One I like came from Josh Bleeker, who we've had on the show before. He asked about union-typed JSON. So in other words, you have a field that is either a string or a slice. And right now it's very cumbersome to do that. There are ways to do that with the current implementation, but could we add first-class citizen support to do this thing? And of course, then there's the question, okay, that's a great idea. We'd love to do that, but how do we do that? What would that API look like? So there's a long discussion about this. It has 27 replies. So there's a lot of little things that go into this discussion. It's an interesting discussion. Even if you just want to lurk and read, you're going to learn a lot about JSON and Go and how these things pan out. So I think it's good reading. Go check it out. I think the Mathrand V2 was the first proposal. That one pales in comparison in terms of, I think, impact. I mean, as Joe said on last week's interview, encoding JSON is apparently the 5th most imported library from the standard or package from the standard library. Behind obvious things like FMT and IO, you need everywhere. So, it's an incredibly popular package. So, of course, there's a lot of interest to get it right.
I think it's a good chance for self-reflection as the software developers. How did we end up with curly braces JSON as our international format for data and not better ones? Insert one of 17 standards here. Each one can, everyone can vote for their favorite.
If you're listening and you missed last week's interview with Joe, I encourage you to listen. Joe surprised me that he thinks JSON is near perfect. That's not an opinion I hear very frequently.
It's easy to complain, but it's hard to actually find better things.
Yeah.
So I'm going to take the easy route and complain.
Awesome.
One small release we wanted to highlight this week is Viper. So you probably use the Viper Cobra stack somewhere for setting up CLI applications and then setting up configuration. I really, really like using Viper for environment variables and stuff like that. It's my go-to. And they just released with slog support, so that's great. It's a small breaking change, but it's a change that breaks in an experimental feature, so you'll probably not notice it. But if you want standard logging from Viper, now you can have it. They just get the interface, the standard library slog interface, as you can pass it with Logger, which is great. It's nice to see the dissemination of slog to the big libraries. I think it's a good move. Any big library in Go right now, that has logging, should in the next few releases start supporting slog, because it is taking a really good hold. It's good to see that the standard implementation is actually getting accepted.
Right. Moving on from hard news, so to speak, I found an interesting discussion on Reddit this last week that I thought was worth calling attention to. On Reddit? Yeah. Can you believe I was on Reddit this week?
I can believe you were there. I can't believe you found an interesting discussion.
So the question and the title of the discussion is, what problem did Go actually solve for Google? We probably all know that Google created Go, sponsored Go, and they still do sponsor Go, although they've sort of given it to the community by now, but they're still, it's mostly run by Google. And we all hear that, Rob Pike and others at Google were trying to solve problems. And the poster says that he's been watching Rob Pike's interviews and YouTube videos where he uses the phrase Google's problem frequently. And so the asker is like, what was Google's problem? And I think that's a really nice question to ask, something we often forget about. What problem was Go meant to solve? And of course, it wasn't a single problem per se, but there's some great discussion here. The most upvoted answer gives a sort of bullet list of several of the problems. Some of them are more or less canonical within the legend of Google or the legend of Go. Others might be a little bit less obvious. Probably the first one that probably jumps to anyone's mind is fast compile times. As legend has it, they were waiting for C++ to compile when they started discussing Go. The very first stages. But beyond that, easier to understand code for new developers, stricter style, which I think is closely related to easy to understand. Wanted to make it easier to write concurrent code. If you've ever written concurrent code in C++ or C or any other older languages, it can be pretty tricky. You get a lot of security potential problems or data races and so on. Go doesn't make that impossible, but it makes it easier to do it correctly. And then long-term language changes are minimal. So the Go one promise, the idea that Go will virtually always be backward compatible. So if you have code that was written 10 years ago, you can still compile it and run it today.
And with the recent backward and forward compatibility blog post, so super cool to see the Go one promise. That they thought about 2009. I think maybe the first email was 2007. Still hold up today. Means really smart people made the promise. And you mentioned all code looks the same. It's better for easier to understand. I agree, but it's also important that it's easier to understand for machines, not just for new developers. It's a lot easier to write tooling and linting and stuff that the developers want, and to write automations when there's no two ways to do one thing. Calling back to the zero proposal, it would be every place where you look for nil, now you also have to look for zero. So they don't want that. And in the same way, making sure that everything is formatted exactly the same way, and there's no two ways to do things. And the language is very easily parsable. It doesn't have macros, doesn't have anything like that. It makes it very simple, which some people look at and say, oh, it's not good that it's simple because you can't do complex stuff, but it's really good that it's simple because you can't do complex stuff. That means that if you have hard problems, you have to solve them with simple solutions. You can't solve them with complex solutions. I think that's a really good move on their part. But it would be interesting to get a Googler as an interviewee. Let's see if we can make that happen. If you're a Googler and you listen to our podcast, jump on the show. Talk to us.
Well, Joe is an ex-Googler, but we just talked about Jason, so... Anyway, I think we have one last story to cover.
Yeah, so I'm so happy we were finally covering this. This has been in our backlog for 2 months now, so it's not super new news, but it's a really, 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 really good blog post. It's called The Deep Look into Golang Profile Guided Optimization, PGO, which, as you probably know, is one of my favorite new features of the language. And the reason I really like this blog post is because it really goes down to the bits and bytes. The thing it does, it just gives you the commands that, the sort of behind the scenes, how the sausage get made, like plumbing commands, get to the code real quick, and teaches you what PGO does. So I didn't know, for example, if you want to see what the compiler is doing to understand which optimization it's running, you can run -gc flags -m when running go build. And you see all the compiler optimizations. It will tell you, I'm inlining this call, I'm inlining that call, I'm argument does not escape, I'm escaping it to the heap, a ton of really, really cool stuff. And you can just compare the output with or without PGO. And also, after you compile both binaries, this is another thing I learned from this blog post that I wasn't aware of. You have a thing called objdump in the Go tool chain. It's called Go tool objdump. And it just sort of gives you, the binary representation of objects before you. In this blog post, they use it to compare before and after PGO. It sort of gets into assembly, so if you're not a super low-level developer, this might look a little intimidating. But this blog post goes through a really, really good example of setting up a simple API server with JSON serve and comparing the results before and after PGO and see how the compiler does it. And some recommendations. A really, really good blog post. It's been in our backlog for 2 months, so I implore you to read it because it stayed alive in our backlog for 2 months, which means it speaks volumes to how well I think it's written. Shout out to Yaha Sayad Arbabi, maybe, for this blog post. It's only that one on the blog, so I really hope to see more from you because this was a really, really good one. I enjoyed it a lot.
Reminds me of the conversation we had with Peter Sivak a few episodes ago. I think it was episode 31. We talked about
Siebes.
Performance. Siebes, yeah.
Yeah.
and he kind of opened my eyes to some of what PGO does. So if you're interested in that topic and missed that episode, go back and listen to episode 31. Had a great interview about that.
So we're gonna have a link to this blog post in the show notes, and go read it. And I really love seeing new blogs with just one post, all the potential. So go show that bloggers some love, so we get more content like that, because it's really good content.
So that wraps it up for the news for this week. Stick around though. After the ad break, we have an interesting interview, a funny interview with Timothy Stiles, where we talk about using Go to hack DNA and things like that.
Yeah, it's definitely a field that most people listening are not aware of, and Timothy is really doing some groundbreaking work there. Funnily enough, mostly parsing JSON. So
yes,
writing and parsing JSON. So it's all coming back to that in the end. So stick around for the interview. So before we jump into the ad break, many people reached out, and thanks a lot for anyone who's wondering if I'm doing okay. I'm fine. My immediate family have not been harmed. Some friends have. Some friends have been kidnapped and killed. This is not an easy situation, but this is not a political show. You're not here to listen to it. If you want to get informed and learn more, you can support and do whatever. You can find a ton of resources where to do it online, or if you're in Israel in person. If you're in Israel, I just wanted to say thank you for all the people who were worried, and some people offered, if I need a co-host to replace, because things are seriously crazy right now. I just really appreciate all the support. Thanks, everyone. And we decided to run the show just to keep some normalcy. It's also good for me to have something to do, here and there. And we won't get into the politics. We won't get into the situation. I'm fine. My immediate family is fine. And we're just trying to get through this situation. Thanks a lot, everybody, for the support and for listening. And let's get to our ad break and some interesting updates. And after that, we have a really interesting interview. This episode is sponsored by Koyab.com. Koyab is a developer-friendly serverless platform to deploy apps globally. No ops servers or infrastructure management. And dear friends of the show, they've been sponsoring us for a while now. You can run web apps, APIs, event-driven serverless functions, background workers, and even cron jobs. I've been using Koyab. It's great. It works. And, I got to the paid tier finally. So I'm finally paying them back a little bit. But they've made me a lot more money than I pay them. So that might say more about my business sense than their servers. But it does work. They have an interesting update from the beginning of this month. They can't stop releasing features. But they have two really interesting highlights. One of them is managed Postgres. So they started onboarding users to their new managed Postgres offering, which makes a lot of sense, right? You have a backend service or a web server or whatever, and you want state. So now they offer Postgres. If you had to pick the next database that they onboard, maybe we can affect their backlog a little bit. Which one do you like most?
Me? I want CouchDB.
You're so predictable.
Because I maintain the CouchDB SDK for Go, so I have to pick that one.
I would just pick a super esoteric old one, just to
like CouchDB.
People's perhaps, but let's do a data log or something. I don't know. Anyway, they have Postgres, which is the actually useful one, and if you want it, they let them know in the comments of their changelog, and they'll reach out to onboard you. And the second thing is that they have a new instance type called free.
What?
Yep. This new edition allows you to run a service for free. It's right now only in Frankfurt.
It's close to me. That's cool.
Yeah, if you want to create more services, you'll need to use other instances types, which makes a lot of sense. But I think it's really speaks to how Koyab is user friendly. And if you want to start using Koyab, use the link in the description. Thanks a lot, Koyab, for sponsoring this show. So what updates do you have for us about the show?
So I have a couple of exciting updates. The first one is September was a record-breaking month for the show. We had more downloads than ever before. We had almost 5,000 downloads in the month of September. Previous record was about 4,300 2 months before. We're generally on an upward trend, so keep sharing the show with your friends and your colleagues and your pets and anybody who has ears because it's great.
Thanks a lot for listening and sharing, everyone. It's what keeps us going. So we started this show mostly to educate ourselves about the news, but we've been really, really happy with the community that's sprung up. It's a good chance to mention that if you want to join the community and not just listen, you can go for Slack. We have a channel there, cup-o-go. Then you can find all the links and ways to reach us at cupago.dev. You can email us at news@cupago.dev. So, keep us on an upward trend. Share it and come join the conversation.
Speaking of upward trends and ways to listen, do you know about the newest way to listen to the show, Shai?
I guess there's some plugin to links, so I can listen to it from my terminal when browsing Cupago.
Or with curl, just pipe curl command to VLC. No, the new way to listen is on YouTube.
Oh my God.
Yeah. So I don't know if we talked about it on the show, but Google Podcasts is being retired sometime at the end of the year, I think, or next year.
Yeah. Move to a farm upstate next to Google Plus and Google Hangouts.
Exactly. And they're being replaced with YouTube Music. And YouTube recently started allowing publishing of podcasts from Europe. It's been available in the U.S. for a while, not in the U.S. As of yesterday evening, all of our episodes are available on YouTube. We have 0 subscribers so far. So if you like to listen to your podcasts on YouTube, go subscribe. YouTube.com/@cupago. No kebab case there, no spaces, just Cupago. It's really audio only. I mean, there's a still image there of the cute Brewster. But otherwise, it's not really video content. But you can listen to us on YouTube from now on. So check that out if that's something you like.
Cool. If you're paying for like YouTube Premium, YouTube Plus, YouTube Red, I don't know how that one's called. It should be really comfortable. I heard they have a really good experience for, listening while on the road and whatever. If you do listen to us from a terminal piping, direct binary content into one of your network interfaces and hooking up a cable and a decoder, that's cooler. Use that. But if you don't use that and you want to check us out on YouTube and subscribe, then you can do that. Now I'm officially like a internet influencer. Like and subscribe, please. Don't forget the bell or whatever.
Ding.
Yeah.
Stick around for our DNA interview. It's a fun one.
Yeah, we had a really fun conversation with Tim. Check that out. And thanks a lot for listening, everyone.
Until later.
Bye.
Hey, Shai. You know how as engineers we're always reviewing each other's code, and we're talking about code smells, and I think we're pretty good at removing code smells, right?
I'm not even willing. I'll play along, but this is even for me, it's a stretch. I also hate code smells.
Yeah, I've been coding so hard lately that my shirts are starting to smell. How can we get rid of that smell?
So I heard, we're programming in Go. So I heard about enzymes and laundry. If only we can connect these two issues together, but I don't know who to talk to.
Hey, Timothy, do you know anything about this?
Yeah, I sure do. Okay, you just call me Tim. That's the easiest one. But yeah, no, so I guess we're introducing me. Hi, all Cup of Go fans out there. My name is Tim. And before we started, I told these two about a lovely biologically engineered concept where the true promise of synthetic biology is that everything should grow on trees. Just why not? Mm-hmm. And I mentioned to these two that, sometimes we work with enzyme sequences, and Shai just said, all I know is that's in the laundry detergent. I was like, that's perfect. Because a couple of years ago, I came up with the idea of, enzymes are sort of like nanobots that your cells produce or cells in general produce. And I was thinking, why don't we just grow these Tide Pods on trees? Why don't we just have berries? And I ran around this conference where all my friends were. And eventually I talked to one friend. She was like, Tim, that's a thing already, right? I just kind of was shocked. Like, what do you mean there's Tide Pod trees already? It's ridiculous. And it turns out there's entire genuses of trees that produce low-grade detergents in their berries. The one that I'm familiar with is soapberry trees in Hawaii. And crunchy hippies have been putting it in their laundry for decades. And so I was thinking, maybe we should engineer these soapberries to have those enzymes, because those enzymes, if you've noticed, it's a lot harder to get permanent stains in clothes nowadays. And that's because we've engineered like 5 to 7 enzymes that are really good at breaking down blood stains, grass stains, grease stains, all the common stains you'd run into.
Somehow my kid still manages. So the science is still
talented. I know it's hard. Like, I don't have enough children near me to know. So, like, also not enough grass either. I live in San Francisco. There's, we have some parks here and there, but not
all right.
the same.
So I can't believe we're doing this in a Cup of Go interview. But first of all, this show is non-medical advice.
Oh, thank God! Yeah,
don't eat the Tide Pods.
No medical advice here. Goodness, people. No, you're right. People ask me medical advice. I'm like, guys, I'm not a doctor. Like, I come up with stupid theories for my own health too.
And before we dive into, why are we talking about enzymes on a programming show, we have to shout out Mihai Tudor. He's a past interviewee. If you remember, he talked about Benthos together with Ash, and he's the matchmaker. Before we went on our summer vacation, we asked for interesting people to talk to, and Mihai was gracious enough to mention you, Tim, and that's why we're all here to talk about Poly, which is a Go package for engineering organisms. Now, most of our listeners, you can see it from our Slack conversations, our Slack channel, and the stuff we usually talk about. They're into maybe backend development. Some weird ones like Andrew are into desktop app development. That's already out there. Like, people will be really desktop applications in Go. The really, really crazy ones are, into WebAssembly. And here you come out of left field, engineering organisms. So for, I guess, most of us who don't even know what that means, what does that mean?
That means engineering mostly cells, not, whole organisms. Some people do whole organisms, right? But engineering cells to produce a certain chemical reagent. So imagine the same breweries that you have your beer brewed in Milwaukee also are just contract breweries, and some companies will engineer yeast to produce stuff like vanilla flavor in large quantities, and they'll brew it up in this vat, just the same way you brew beer. And instead of selling the beer, they extract the vanillin and sell it. And that's sort of like the core principle here, is that the idea is that you're engineering cells to produce some valuable chemical that you can then sell. But it also has applications in medicine. So if you can program your human cells to produce a medicine internally, that's a pretty good therapy.
So how do you do this with Go? Like, this sounds like I need a microscope and like tweezers, and I don't know what kind of equipment you use to this, or droplets and whatever. How do you do this with Go? How is Go contributing to this?
So this is, I can tell you the story behind this. So I originally got into the field, and there wasn't like a good, not even central, but a good framework for engineering DNA. And that's what Poly does the best. What Poly does is it offers a set of parsers for these old legacy data formats that literally I'm having someone write a parser right now for it. And like, this is awful. I'm like, yeah, so were all the other ones. Huge, terrible, not even XML, not even ASN1, which most listeners probably never heard of. It's like these data formats that were specified by the U.S. government in 1978 in the deserts of New Mexico. And we don't know who to blame for it. It's all white space based. It's awful. So we start with the parsers, right?
Okay.
The format is GenBank, right?
GenBank. One of them may. There's but GenBank's my personal pet peeve. That's the one where like I've been trying to find people who made it forever just so I just want to talk. I just want to know what was happening when they did this. Just want to talk. Because I think it takes longer for me to write a parser than it did for them to make the spec for this thing. And so what Go provides is, when I was designing this initial library, which there aren't many libraries for designing DNA, there's very, very few. When I was designing this library, I had a choice between what most scientists already use, Python and R, and then Go and Rust. And I know plenty of languages, and that was sort of the, do I go down the path of least resistance where all the developers in science use Python, or do I pick something that compiles to a binary and goes fast? And I thought at the time I was going to have a command line utility, because that's just sort of how scientists expose their programming to other people's command line utilities, almost always. So originally Poly shipped this command line utility, like just turning GenBank into JSON. And I tried Rust and I tried Go, and Rust was just, the string manipulation in Rust is kind of unique. I forget how they do it, but it was enough of a problem. I couldn't see Python devs making it to that point, but I could see them going to Go and just go one out on everything else. It was just a mature system at that point compared to Rust. And so that's usually been a sticking point of a lot of scientists to say, why Go? It's like, well, how you have to set up virtual environments and Docker stuff like out the back for every science project you do? I don't. I've held entire hackathons where like I haven't had to help a single person install for dev stuff. The basic defaults for Go are really beautiful if you don't have an opinion yet. Like example tests are great. That is a built-in feature that most languages don't have that. I don't know if Rust does. I'm pretty sure Python does it. There's third-party packages for it, but like that's what kind of got me excited about Go. Is there was enough opinions there that like I was still learning, and it just kind of I was like, we should really just write these tests as examples. And it was like someone's like, we can just do that, right? And it was great. Like then sort of like
sounds like you're coming up with all the good ideas that are
no,
trees that have Tide Pods and example testing.
No, the good ideas,
fantastical ideas,
that someone's already figured out. Man, I'm not that smart. Like I kind of like I stared at it for a second. I was like, oh, that does make sense. Okay. And I think Go does that really well. The standard library and the standard tools that just come with Go are great. They make it really easy to pick up, very easy to learn. I've had people learn Go in like a day or two and actually get, contributing with stuff like almost immediately. And sure, there's some tricky parts that, people can get stuck on. Generics and interfaces have been introduced last 2 years? Or generics have anyways. And, there's some things with Go routines that can be a little sticky. Like we've had people write stuff with Go routines that's like actually slower than just doing single threaded stuff. But overall, as a default programming language for science, it's pretty good, especially since we're not messing so much with matrix multiplication, which is usually what a lot of scientific applications are doing. So essentially, deep learning, machine learning, it's just a lot of matrix multiplication. With bioinformatics, it's usually just string manipulation. Every programming language does string manipulation, right?
Not all of them do it well. Shout out to my days working in Lua, where it's one based and, all your world shifts like off by one. You start programming in Lua, you miss every step on the stairwell, like the first step every time. So again, trying to go back to super basics, what I'm imagining is I'm a company that produces something organic, right? You said not a whole organism, right? It's not going to be easy to program a goldfish using JSON.
Look up glowfish. That's actually a genetically engineered pet that you can buy. They've been around since like the late 90s.
I don't know. I'll look that up, but I don't know if we can put it in the show notes and recommend because I don't know, maybe. But anyways, let's go run with the laundry example because I think that's at least for me easy to understand. So this company, they have scientists, they're working in a lab and they're trying to iterate to find the best enzyme to clean clothes, right? It's something that everybody needs. It's hygienic. It makes sense. We were trying to figure out ways to produce it and whatever. They cracked the case. They have the best enzyme on the market. Now they can use, Poly to just send a JSON file that includes this material over bytes. And then on the other side of the world, using Poly again, they can decode it and remake it, and it's exactly the same.
Close, very close. So there's a couple of steps when you're going when you found the enzyme sequence you want. Imagine these are just long ticker tapes of just instructions. The A, C, T's, and G's, this is just coordinary instead of binary. And there's ticker tape instructions where essentially these directly translate into what are called amino acids. And these little amino acids are kind of like molecular magnets where they will fold against each other and start revealing these shapes and configurations that do special things like break down blood stains in our case, or like grass stains in our case. And so what Poly does better than anyone else or anything else is we do two things: codon optimization and DNA synthesis optimization. Those are the two things that are relatively unique to our package, but it's something that everyone needs to do. And so codon optimization is, it turns out that the ribosome, which turns these DNA sequences into proteins, these nanobots, they're like compilers. And it turns out that different kinds of organisms have different kinds of compilers, and they read the language differently. So if you want to take a gene from, say, like a human and put it into corn for some odd reason, I don't know why you would, but say you want to put a human gene in corn, you have to recode it so that it's optimized for corn, because otherwise it may come out misfolded and weird and not do what you want. So these sequences, like, you can make minute changes to it without changing the end result nanobot. And that's really helpful for a lot of reasons, but the one that we focus on is DNA synthesis optimization. The chemistry that we use to print genes de novo, literally think of it as like HP printers are like actually in this field. They print DNA on silicon chips or paper layer by layer with inkjets and bind them like that. It's a statistical process. And there's a lot of potential errors there. So, for example, if you have a lot of repeat base pairs, A, T, 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 it's really hard to check, they sequence this stuff for quality control afterwards. It's really hard to do repeat nucleotides. So, that's just one thing this function filters for. The other is enzyme cut sites. There are enzymes that cut DNA at certain locations. We know where they are, but there's a ton of enzymes. There's 30,000 enzymes we use commercially. I actually have to go look that up, but there's quite a few. Mm-hmm. And you want to make sure that whatever you're doing downstream for your from your engineered DNA doesn't get mucked up by the enzymes you're using for some special procedure.
Damn. And the way you would introduce poly into an already existing organization that's already working and whatever, what are they doing now? Without these parsers, without that?
I'm gonna try and be gentle. They're getting lucky. And a lot of they're writing internally, so there's a couple of things. A lot of these companies have to write this stuff internally anyways. That was the one thing I noticed, that if the companies are really doing this, they're writing it all internally and they're spending millions of dollars of dev time just doing it internally. It's like if every company made their own web framework, closed sourced internally.
What, they don't?
Maybe they do, right? But that's pretty much what biotech does, is they make their own framework internally. And then the person who made it leaves the company and it just starts to rot really fast. And it becomes this huge burden of technical debt, because it also turns out that a lot of software engineers don't understand biology. So Poly's answer to this is that we've made this really stable code base with a lot of unit test coverage, a lot of examples in there to make sure that, so if I look at it 10 years from now, I should be able to at least grok what was done. And that's sort of been the benchmark so far. It's people wondering hey, this works. Why aren't they accepting it? It's I don't understand it. Someone needs to fix this 10 years from now.
Building for the future. And by the way, I'm thinking about the other way around, taking a gene out of corn and putting into a person just to create another awesome band. But that's just because I like corn.
Yeah, so, there are...
Wait, I didn't mean it seriously. You're not going to tell me that people are taking vegetable genes into themselves, right?
No, there's DNA from weird places does weird things. So, one of the most frequently used genes in science is called GFP, green fluorescent protein. That comes from jellyfish. That's why a lot of biotech companies' logos are jellyfish. And so there's green fluorescent proteins. You can use them to tag certain other biological markers that you want to see visually, and just shine a light on it, and will give you back a green light. And then if you think about, so polymerase, Taq polymerase is what copies DNA, right? And that's what Poly is named after. The polymerase we use is actually found in a thermophile microbe living, I think, in the sulfur, the sulfuric pools in Wyoming. And we found it in there because it's thermostable beyond a certain temperature, which we need. And so a lot of the biotechnology breakthroughs that we have are just by finding weird organisms that we know exist, in certain conditions, and finding some protein in them that we need that, meets the condition of it's thermostable, or it can be in high salt concentrations.
This doesn't sound that different from the game my 2-year-old plays, where he takes the head of a giraffe and puts it on a donkey because the donkey can't reach the trees. There's a trait from this animal that would fit on this other animal. Let's just put them together and make a better animal.
A little bit, right? I think there's a little bit more of there's a lot more ethics to it, right?
Yeah, right. I'm not trying to make it as simple or silly, but conceptually, it sounds like this thing survives in hot water. Let's use that trait, and it glows. Let's use that trait, and whatever.
Yeah, that's exactly it, and that's something that we've been doing for a while. Biotechnology has been mostly borrowing from nature until very, very recently. We've developed some machine learning models for protein design that sort of, they're de novo, right? They're new, but they're still based on old stuff. And so we're now reaching this frontier of protein engineering or nanobot engineering using biology that can do some really interesting stuff. But historically, we've been almost entirely reliant on just genes we've seen before. And to give you an idea of probably the most important medical application of this technology, insulin production. Most insulin is produced in yeast in these giant vats in Milwaukee, like I mentioned. So that's sort of and that was before 1978, I think, is when this started happening. Before then, it was pig insulin. It just came from pigs. It was much harder to produce and much more expensive.
Yeah.
And even the ethical angle, like, I don't know if vegan insulin is a thing.
Oh, it's been vegan for a while. Yeah.
That's a lot better. I think everybody would agree that's a lot better, even if you're not into the ethical worries of consumption of pigs. It's better for climate change. It should be cheaper. I don't know what's going on in America that it's only getting more expensive, but in every other place in the world, it's cheaper and cheaper.
California's getting cheaper now.
That's really good news.
Yeah, I should go double check. I know there's actually a group here in the Bay Area called Open Insulin that's been working on this for a while. But recently, the state government of California has jumped in on the game of making insulin cheaper too. So that's been nice to see.
We've been seeing a few OpenX projects recently. OpenAI has been doing well. OpenTF we recently interviewed. But if I would root for anyone, it's Open Insulin.
Yeah, Open Insulin, they're a great group. I don't know if Anthony is a Go dev, but he's a computer scientist. Maybe he could show up.
Even if he writes Lua, he's okay in my book. So there's one thing, talking about open, there's one thing worth mentioning about Poly. This sounds like a super, from an outside perspective, really a strong project that I expect like a biotech company is behind and they're funding and they're selling it and whatever. But that's not the case. So this is open source software, right?
Yeah. Yeah. I mean, it turns out when you do something really cool on the internet and tell people about it, more people show up and start doing it with you. And I've found that even internally at some of these biotech companies I've talked to, like Poly's very, very strong. They, a lot of companies have actually looked at Poly to, if not use, they've literally used it for a reference implementation for something they need. And that's like a common thing. But it really sort of came out of during the pandemic. I have a good friend who was at a genetic engineering lab at Stanford and was moving down to his parents' place in Los Angeles because of the pandemic. And he just didn't want to be alone in the Bay Area anymore. And he called me on the drive and he told me that he couldn't convert GenBank to JSON and back using Python. And I was just kind of like, what? This is this is the baseline, right? This is like what you need to get stuff done. And so he asked me if I could write a parser for it, and I took a crack at it. And it worked. And I was like, yeah, don't use this in production, but like it works. And so he used it in production, of course, almost immediately. And they did really well. And we started building stuff together. And people sort of like, in the first like half a year, it was only like 2 or 3 or 5. Like, I think it was like 5 people were like worked on like certain parts of it. It was mostly just me and Keone. And then it sort of kind of took off from there. And it turns out that biotech companies have this problem where they don't know how to hire and manage software engineers. I think this is the biggest problem for software engineers in the field, is that almost every company that has the word tech in it is becoming a tech company, biotech included, and they need to know how to write software. But what ends up happening at these companies is that the founding team usually doesn't have a very technical person. Usually they're all scientists, maybe a business person, right? But there's no software engineers on the founding team. The CTO is often a scientist who does science things. And so, they don't even know anything about web dev. If you ask them like, hey, what's a post request? They probably don't know. And so they're tasked with hiring like the first programmers and then the next programmers and the next ones. And what you'll find is they don't know how to attract talent and they don't know how to manage talent. And this is just like across the board in the whole field. It's like this. Like biotech salaries are notably lower, especially for software engineers. And it's changing now. A lot of companies have now changed their model. They're now realizing that they should invest in this. But for a while, it was like, it was hard.
I have a friend who's a mathematician and he's just getting into software. And, I brought him into software, so I tried to do it the right way. We picked an open source project, very easy, in Python, where I know the maintainers, they're friends. It's Keep, which we mentioned on the show, by the way, Jonathan. And, I taught him like, okay, this is how you install Git. This is how you write a unit test. And this is how you use Poetry. And this is how you open PyCharm. And this is how you run a program. And then let's get into Python, right? How to write like loops and whatever. And he went into like a super deep research project, deep learning, whatever. And he's starting to teach them. Like, this is version control. Have you heard of it? No, they're using email to pass files back and forth. How do you write they're opening Notepad on Windows to edit the files. Yeah. Like there are some basic software engineering stuff that these people, I guess, it's not therefore they instantly fair that they don't know because they're scientists and their focus is totally different.
And so the phrase I've been calling this Tim's inverse law of software quality. More important the thing, the worse the code. Like rocket ship code, probably not that great. Instagram code, I bet you it's got some quality control behind it. And like there's a lot of reasons it's like that, but you're right. Scientists aren't software engineers, and they haven't had this expectation. And something I tell a lot of scientists is that there's been a new computational focus, the last decade, right? I've been telling a lot of them, hey, look, your advisor for your PhD program is not going to teach you about unit tests. They're not going to teach you about Git or the command line or how to manage dev environments. You need to learn that. Your advisor may even know you need to learn that, but doesn't know how to teach you that. And there have been some programs, like I think Mozilla had like a program for scientists learning how to code. I think there's been like the software carpentry and data carpentry groups. I don't know if you've ever heard of them. But they worked a lot with getting scientists sort of up to speed with basic dev practices. Because you're right, most of the time they're doing math or like running a machine and getting results from some machine. They're not specifically focused on code, but they have to use it now. They have to even publish it. And if you look at the code that's published even in like highly prestigious journals, right? I've seen some gnarly Perl scripts, like just in like Nature Genetics, that it's just spaghetti. And it's published in one of this is like it's like being in Rolling Stone magazine as a musician. Like this is the place to be. So the bar is low, but it's also weird. It's a weird bar to be in. Because you have to understand this biological context. I think a lot of computer scientists and software engineers come into the field feeling kind of cocky because they see people using Notepad, right? Or emailing changes back and forth. And they're like, these guys don't know anything. Well, no, they do. They really understand the science. It's just the software stuff. You need to be able to not only do it, but you need to be able to explain to these groups why it's important, how it's going to save them costs, how it's going to save them time, and how it's going to make their organization just work better. And I've had interviews where I interviewed with a company. I was like at this point, code optimization and DNA synthesis optimization were like done. We had finished these features, and there's only like 3 or 4 people like on their resume publicly that are like, I wrote this. There's a GitHub repo for this, right? So this company reaches out to me. They're like, hey, do you want to interview for this position? You look like a really great fit. And the position was exactly just DNA synthesis optimization. Like, great, I can do that. Let's talk. And I get 30 minutes through the call, and I realize that the job she's talking about is not for DNA synthesis optimization. She's asking like, hey, can you help us set up GitHub? And we need stuff like in the cloud. I was like, they were describing their quality control process. Essentially, instead of like having, all these computers at least network together and like passing data between each other on a local area network, they were taking USB sticks from different machines, like from the sequencer to a Windows machine to a Mac, and doing that. I was like listening to this. I was like, okay. So I asked her eventually, like, is this position? She goes, oh, no. We're not doing that position anymore. This is for the, I think she was like, this is for the guy working underneath the guy that developed this. And I was like, I can't do this. Like she was asking me to she was asking me to help set up GitHub for the entire organization. I was like, you don't have GitHub yet? I was like, I can't do, like, there has to be at least an appreciation in the org for these sort of things. Like, they're like, there has to be some knowledge that something's missing, because a lot of these companies, they don't know until their investors tell them in some cases. Like their investors will be like, whoa, hold up. You're changing the world and you're emailing changes back and forth in a thread for your code. Wait a minute. I've invested in at least one tech company. I know what the difference is, guys. Don't do that. And like, it's very, very easy to be cocky, but the humbling thing here is you have to realize that they're familiar with so much like domain specific information. And it's, I picked it up over time, but I feel like a lot of people sort of miss things. Even biologists can, some like varying levels of degrees, like miss things. Like a good friend of mine learned that you have to optimize for codons. She didn't realize there was different codon, tables or different codon translations between DNA and between RNA and proteins. Like she just learned that.
I think it's easy for software engineers because software engineering, at least nowadays, is pretty easy, but it is very empowering. Like after a year in programming, you can do really cool stuff and it pays really well. I think many people get a false sense of just their capabilities and how easy everything is. And, if they understand this one complicated thing, like web development or, crypto or whatever, everything else is easier by comparison, which is just not. And I've seen this fallacy a few times.
Scientists have the same problem too. I'm really good at science. Oh, I must be good at code. It's the same problem for as soon as you're really good at one thing and you're like, wow, this is easy. You're like, I bet everything is easy. And then you start realizing, oh, wait, hold on. This doesn't translate at all.
Yeah. So just to get back to the open source side of things. So this is open source, but obviously a lot of companies can use it. You're working on this project full time now, right? How does that work?
So Poly has been supported by various different contracts, full-time gigs. I've been doing it full-time since 2021, I believe. I'm trying to remember. And right now we were accepted to GitHub's first open source accelerator. I don't know if Mihai actually told you about that.
No.
Yeah, GitHub gave us like $20K to be part of their first accelerator, no equity taken. It's a really great program, really nice. And now we're raising money for a startup.
Oh my God.
I know it's weird because we're starting to hit that limit of like, I've been told you need to talk to 100 investors. I think we've talked to like 30, and now we're starting to know the game now. There's a real game with investors, but we're starting to get to that point, and it's sort of challenging. It's because like good investors will know what you do, and not good investors will not know what you do. It's kind of common. So we finally got like a new advisor. He was the CTO of a company you've definitely heard of, but it's so new. I don't want to press embargo, annoy my CEO, blah, blah, blah. But we finally got an advisor that really gets it, who understands that we're building essentially dev tools for people trying to move from software to biotech software. And our first product is really just enabling people to store and query data easily. There's all these little quirky things that you wouldn't expect from biological data that make it hard to search and store, that we're trying to abstract to make it easy for the end developer not to have to think about. They can just say, I want something like this, and we give them something like that.
That's really cool. All right. So we talked about what Poly is, and I don't know how many people understood it. I feel like I have a ton more to learn. And we talked about the Go angle, why using Go for it, which is super cool. And we even talked about the like business aspect of it, right? How you started with open source and where is it going right now? If people want to learn more about Poly or just talk to you and, get involved because this sounds super interesting, or maybe they even need it, maybe we do have biotech listeners actually.
You'd be surprised. You probably have a couple.
So where can people reach you and where can people support the project?
So I would say go to project's GitHub link, which I'm assuming is going to be in the notes for the show, and just sort of read about the project. Join the Discord. We have a Discord that's, at least like almost 300 people. And Mihai Todor is actually on there. That's where he told me like, hey, do you want to do this? So Mihai's there, and there's a bunch of really interesting people just sort of in chat, and we're all sort of working together on similar things. And I think that's the best place to start, is looking at the repo and just joining the Discord. It may just be that you're lurking, and that's totally fine. Or maybe you just jump in and start really working on it. Like some people show up with like a huge gung-ho attitude, and then they're like, oh wait, I don't have time. And some people like, I don't want to get too in, and then they get too into it. I like both. They're both just peachy to me. As long as people are there having fun, that's what I want with the Discord group.
So I'm wondering which approach Jonathan took and which approach I took. Which one of us was the gung-ho, let's do this, and which one was, maybe I don't want to get into it in the podcast for this podcast. Because I feel like I went in with a whole bunch of energy and like set up the Trello thing and whatever, and then Jonathan was more careful about it. But we found a good balance, right? I think you'll find a few in each project. And if people want to talk to you directly, where can they find you other than the Discord?
Usually I tell people to pull my Git logs from the project and use that email. That's how I keep the recruiters out of my email. They're pretty rough. They've been asking me to do crypto work. I'm like, guys, did you even look at my GitHub? But Tim@stiles.io is my personal email. I don't know if that should be shared on the show or not, but that's a good place to reach me. I typically see things there. There's no bots scanning the audio for my email.
No, there is not.
Yeah, okay, fine, yeah.
We're not famous enough for you, I think it's just the right balance. The show Slack group right now is also around 200 people, so it's still a small village. It's not a big city yet.
I like the small village. I mean, it feels a little weird because sometimes there'll be certain points where there's like a real lull in conversation, like it'll be a couple of weeks, and then like all of a sudden it's just spring forth of just text, just lots and lots of messages. And I'm just super thankful when someone like shows up to the community and it's like, oh great, there's a wall of text. Good. They think we're on this all the time. But I'm pretty happy with our Discord. But you can reach out to me in my email. Discord's fine. If you live in the Bay Area, I'll probably be doing some meetups soon. Not sure when, but I live next to one of the Bay Area's local hackerspaces. Not next to, but like 3 blocks away. And it's just a really convenient venue. So I'll probably be working out of there a little bit. I'm actually surprised at how many contributors end up being in the Bay Area. I think like a fifth of them are in the Bay Area just by chance. So I want to throw them, when we raise some money, I'd like to throw them at least a nice dinner.
Some swag. I think the icon from one group that has a really cool icon to another. Your project icon is one of the coolest gophers climbing on the DNA ladder. That's really, really, really cool.
That was done by a UC Berkeley student, actually. That was like he's like, how can I help with the project? It's like, we need a gopher that does something with DNA. He's like, yeah, I got this.
10 times UC Berkeley student fully understood the assignment.
UC Berkeley, yeah. UC Berkeley has all these super motivated kids, and sometimes I'm just like, you guys, I don't know if I have enough energy to keep up with this level of motivation. But they get it done. They're really great.
Well, we've been talking for a while. I feel like I could sit and talk for a long time. I have so much to learn about this, just out of curiosity, because it's a field that I'm not familiar with. But to respect our listeners' time, we need to wrap up a little bit. We always like to ask our guests 2 questions. I think you've been prompted on this, so it's not a complete shock, but I'm going to throw a twist in at the end, given the topic for today. But let's start. Somebody is holding a gun to your head and says, Tim, you have to take a feature out of Go. What would you remove?
I don't like interfaces that much.
Oh, wow. Okay.
I'm not a big fan of them. It's nothing personal. Just like everything around generics is a little iffy for me.
Uh-huh.
Yeah, but I don't have like extremely strong opinions. Like it's just sort of like I've defined one type that had like what was it? Sometimes the data types you're working with in biology are really tricky, and just more options when it comes to doing generics be really helpful. That's the adding part too. It's like,
okay,
I could either not have generics or have a little bit more support for generics. But the way it is right now, it's just sort of, it's a nice rabbit hole. One of my contributors is trying to redo everything with interfaces and generics for all the different data types we have and sort of have like one unified sequence type. And it's been hard.
All right.
It's the way of putting it.
Yeah. Okay. That's an interesting take.
I think actually the take is what I would take out of Go is the next 2 years until we figure out all the generics related to proposal and its tip-top shape.
And I mean, like the Go developers, the Go team is definitely more qualified to decide on how things are going. I'm just an end user. It's just my general feeling has been like the generics part is just, when generics first came out, like there wasn't even that much documentation for it. I think that's when I first tried using it. And like every time someone's running into a problem dev-wise with Poly, it's like, are you trying to use generics? And they're like, yeah. I'm like, okay. And I don't know what's going on there.
It is advancing one proposal at a time.
So I want to ask a related sort of question, given our topic for today. I don't know how much you know about gophers, the animals, but if you could add a feature to gophers using Poly, what would it be?
I usually go for plants. Those ones are easier. What would a gopher? So gophers are in the ground, right? They typically, they're not groundhogs, right? I mean,
they're groundhog-ish.
They're groundhog-ish. Yes. Gophers, but they live in the ground. They are. Yeah. Are they? I need some more details about what gophers do. I need to know about gopher society.
They complain about rust mostly.
Oh, okay.
Gophers are small, furry rodents that burrow tunnels through yards in North America and Central America.
And they're cute.
They're cute. They make little squeaking sounds.
They're less cute than hedgehogs, but they're cuter than moles, I would say.
Cute than moles. I mean, yeah.
I don't even know how you're thinking about this long, not just yelling bioluminescence.
I mean, so bioluminescence, but that's like, we have to understand that in my field, we play a game called GMNOs, and this is a classic GMNO one. A GMNO is just like, hey, this is really dumb. We should have made this, but what if we tried? What if? It's the what if game for this, right? So the latest round I played was like, if you could engineer any fruit, what would it be? And it's like, I was like, yo, I'd make hand peelable watermelons. Like, you got an orange, peel it. Watermelon, peel it. That'd be great.
Awesome.
So with groundhogs, like I just haven't held a groundhog in my hand. I don't know what
I can't imagine you'd want to peel it though.
Have you ever held just a ball of watermelon in your hand before? It's actually, I actually carved a watermelon, so it's just a ball of watermelon. Wow. Very satisfying as a hand fruit. But it's groundhogs. Let me just look up groundhog and like see what it looks like physically. Cause like I'm confusing it now with prairie dogs. I mean, I could make it Oh, I could just do a riff on Groundhog Day.
Make sure you look up gophers, not just groundhogs. I mean, if you want to
Sorry,
compare,
not
it's
Gophers.
fine,
Sorry,
but yeah.
Gophers. Let's see. Minnesota Gophers. Here we go. Common for Burmese rodents of the family.
My trade is adding the Minnesota gopher, moving it to the Bay Area, so it can.
You could probably so. Let's see. Oh, I would, just for their own sake, help them. I'd probably find a way to help them deal with their external parasites. I don't know what external. They probably have fleas.
Oh, that's cool. You can take the smell of the pill, like, the collar you give dogs.
If that's a biologic, you could totally do that. So I would. This is actually something I was thinking about because we were trying to get rid of a mattress recently, and no one takes mattresses, right? It's everyone's afraid of bed bugs. It's a terrible thing. Never had bed bugs in my life. Don't know what they're like. I'm sure they're awful, right? But no one's going to take my mattress.
Very, 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 very bad. I can tell from unfortunate personal experience in the army.
Okay, so then and so one of the things I was thinking about when I was dropping off my old mattress at the dump was wouldn't it be great if we came up with a biologic coating that just deterred bed bugs from getting in your beds? That would be great. That would be a great product for anyone listening out there. And so I would probably, just look at pest resistance or parasite resistance for groundhogs, just for starters.
For gophers.
For gophers. For gophers. Yeah. Just bleep it every time I say groundhog, just for gophers.
That's so cool. That's honestly the coolest version of this question we've ever had. The rest of the response coroutines maybe. You are talking about pest resistance for gophers. I think I have to change jobs now. I can't do cybersecurity anymore. I have to do biotech.
Oh, there's also a field of biosecurity, which is kind of funky. Ooh. There's a lot of green space out there. No, seriously, the biosecurity people, they kind of got dunked on by COVID. I'm gonna be honest. They were not ready for that. They've been talking about government level, bioterrorism, and they got done in my bats, dude. It was I went to a biosecurity conference 3 weeks before the pandemic started, and I just it was a local one, so I just kind of walked in. I was like, y'all flew from where for this? Didn't you see the reports? You're from the UK and you're here right now. Go home, dude. The one biosecurity person I knew, I called him later that day. I was like, why are you at the conference? He's like, why do you think I'm not at the conference, dude? So yeah, biosecurity is a fascinating field that's still very young, but a lot of it's trying to figure out hey, what can people really do with minimal resources? And the answer is not much. It's pretty easy to tell when someone's working on something nefarious because you need a lot of equipment that would be indicative of that. There's the only example I have that's comparable is I once visited MIT Media Lab where they had a very expensive CNC machine, and they said it had a GPS in it. And the reason the GPS was in there is because that machine is one of the ones you need to build nuclear reactors. So if that thing gets moved, the local FBI office gets informed that it's been moved, and they show up and try and find it.
Oh my God.
So there's special equipment you need for that kind of stuff that's tracked.
Let me spin that on you. GPS enabled gophers.
I mean, it would make life a lot easier to track. I mean, the closest I've heard of that is my friend claims that pigments, the pigments that, everyone has, that you find in every organism, are antennas. I don't know if this is true. It's kind of hocus pocus to me, but he's like, what if we made Wi-Fi trees? What if we made Wi-Fi gophers? Just gophers that were Wi-Fi extenders.
There was a running joke in my wife went to Beersheba University, which is in the desert region of Israel, the Negev, and the Wi-Fi is really bad there. So the running joke was, the Wi-Fi camel is now on the other side of the campus, and when it comes back, to our side, it's going to be a bit faster.
Can we make a purple camel that's just making Wi-Fi happen? I don't know if that would be too much energy, metabolic energy expended, but that's the.
I would maybe keep it out of the VC pitch deck.
Oh yeah, no, VC pitch deck. So the VC pitch deck,
that'll have to be a bit more grounded and serious.
Oh no, I wouldn't. The VC pitch deck is not my. Pitch deck is beautiful, by the way. To any VCs that write Go out there, the pitch deck is beautiful, and you can ask me about it. It's really good. I didn't make it, and that's why I'm hyping it so much. It's really good.
Well, Tim, this conversation has been mind-blowing. I don't even know what to say right now. thanks a lot for coming on the show. Now that you're on the Cup of Go Slack as well, if people are interested in this topic, they can catch you there as well. But obviously in your email and the Discord, everything's going to be in the show notes. And usually open source work, it's really hard to say it. But for this one, I think the applications could be so good that I just want to thank you for the work you've done so far and really wish you and your partners luck with getting this initiative off the ground. And thanks a lot for your time, man.
Yeah.
This has been absolutely mind-blowing.
Anytime.
Been a lot of fun.
Oh, I just realized I have a meeting now too. All right, time to
Guess we're all bailing.
break. All right.